All right, so I think I'm recording. Let's take a look at problems 22 and 23. They give us a parent function, and they tell us that it's the dashed line. Now, you won't be able to see it as blue on your Xerox test, but it will show up as a dashed line, and this is the square root function. And we're going to apply transformations to write the equation for the one that's in red here. So our first transformations are left and right, and we can see that we're going to shift this graph to the left 3 units. So if that were the only transformations, remember that shifts left and right are before you apply the function, before you apply the square root, and it's bizarre in its behavior. Even though to the left is negative, we actually add 3. And so my initial transformation is to take that f of x and to shift it, let's call it 1 for our first step, that we shift it to the left. Now we work with this result and we reflect it across the x-axis. So we need a negative sign, and since it's across the x-axis, it's after you've taken the function, it's applying to the output. So our final answer for this one is the opposite of the square root of x plus 3. And you need to have this, I've seen people that have it written like this, where it looks like you're taking the square root of x and then adding 3. Make sure that this is extended. Make sure, maybe even put parentheses around that to let people know that you're not just taking the square root of x, you're taking the square root of the sum. All right, so that's our final answer for 22. Let's take a look at the next one. So here our dashed line, our parent function, is the absolute value function. And again, we're going to the left. Okay, so we're going to the left. Let's have our first transformation. Oh, this is absolute value. So left and right is before we apply the function. Before we take the absolute value, you take x, and instead of subtracting 4, you add 4. And I'm doing that before I take the absolute value. So that would, my v, this absolute value, that this vertex that's at the origin, would shift to the left, and that v would be there at negative 4, and it would be opening upward just like that. Well, then, next, see how my final graph is opening downward. I need to reflect this across the x-axis. I need this to open downward, not upward. And remember that when you studied quadratic functions, x squared opened upward and negative x squared opened downward. That the negative in front of there reflected it across the x-axis. And that's what we're doing here. We've just been very detailed in our description and gone into it a lot more in depth than when you identified ax squared plus bx plus c and said, hey, if a is greater than 0, it opens upward. If a is less than 0, that parabola opens downward. Well, I need this guy to open downward. So in my second transformation, since I'm changing the sign of that y-coordinate, it was up 1 and now I want it to go down 1. The negative sign goes on the outside of the parentheses, not parentheses, of the absolute value symbols, which would be parentheses if you were writing in function notation. So now this one that I've written here in this pink color, I need to lift it up 6 units. Well, that's going to be my final answer. It takes the resulting graph that we've been working towards, and to go up is to add to the output, and it's plus 6, just like you would expect it to be. On the outside, you do the multiplication before you do addition or subtraction, and positive is up and negative is down, exactly kind of what you thought it would be. So there's our answer for problem number 23, and I hope that helps.